90% of Kubernetes clusters are running Ingress NGINX, and it's being abandoned in 16 months with 0 maintainers left.
Wait, abandoned? What happens to production clusters using it? So we're covering the migration timeline, gateway API alternatives, and what this means for existing deployments?
By minute 4, you'll know exactly which migration path saves your infrastructure. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today, we're diving into why Kubernetes is retiring Ingress NGINX.
Stick around to the end for this week's headlines. Let's dive right in.
So let's talk about something that's about to impact literally millions of Kubernetes deployments worldwide. The retirement of Ingress NGINX is happening in March 2026, and based on the latest surveys, about half of you are still using it.
Half? That's a massive number of production systems that need to migrate. We're talking about the component that handles all incoming web traffic from most Kubernetes clusters.
Exactly. And here's the kicker. The end-of-life date is March 2026, which is barely a month away. That gives everyone just weeks to completely re-architect how traffic enters their clusters. This isn't some minor deprecation. This is the equivalent of telling someone they need to replace the front door of their house while people are still walking through it.
But wait, hasn't Ingress NGINX been around forever? I mean, it's been the default choice since, 2017?
That's right. For nearly a decade, if you needed to route HTTP traffic into your Kubernetes cluster, Ingress NGINX was the obvious choice. It's in the official Kubernetes documentation, it's in every tutorial, it's what everyone learns first. And now it's going away because, and this is the real story here, they can't find enough volunteers to maintain it.
Hold on. You're telling me one of the most critical components of the Kubernetes ecosystem used by millions is dying because of volunteer burnout?
That's exactly what I'm telling you. The Kubernetes Steering Committee was crystal clear about this. They said, and I quote, "Despite extensive efforts to recruit new maintainers, the project has not been able to attract enough contributors to ensure its long-term sustainability."
That's actually terrifying when you think about it. How many other critical pieces of infrastructure are hanging by a thread like this?
More than you'd want to know. But let's focus on the immediate problem. If you're running Ingress NGINX right now, and statistically half of our listeners are, you're facing a countdown clock. After March 2026, no more security updates, no more bug fixes, nothing.
And we've seen what happens with Ingress NGINX security issues. Remember Ingress Nightmare? 5 different vulnerabilities that could let attackers bypass authentication entirely.
Exactly. This isn't some random library buried deep in your dependency tree. This is your front door. Every request that comes into your cluster passes through this component. When it stops getting security updates, you're essentially leaving that door unlocked.
So what are people supposed to do? Just rip out Ingress NGINX and replace it with what exactly?
Well, that's where this gets interesting. The official recommendation is to move to Gateway API, which is the new hotness in Kubernetes networking. But here's the thing. It's not a drop-in replacement. The entire mental model is different.
Different how? I mean, at the end of the day, we're still routing HTTP requests, right?
Oh, Alex, if only it were that simple. Gateway API completely changes how you think about traffic routing. Instead of one monolithic ingress controller, you now have multiple resources: gateways, HTTP routes, gRPC routes. It's more flexible, sure, but it's also more complex.
That every one of those millions of deployments needs to figure this out in the next few weeks?
Well, there are alternatives. ChainGuard announced they'll support Ingress NGINX through their Emerit OS program, but that's a paid solution, and it fundamentally changes the economics of what was previously free infrastructure.
This feels like a watershed moment for open source sustainability. We've built entire industries on top of volunteer-maintained software, and now the bills are coming due.
Coming up, we'll dig into exactly what this migration means technically, what breaks, what doesn't, and why Gateway API might actually be worth the pain. Plus, we'll look at the other options on the table because Gateway API isn't your only choice here. All right, let's get into the technical meat of this. When we talk about migrating from Ingress NGINX, we're not just talking about swapping out some YAML files. This is a fundamental architectural change.
Walk me through this. In my current setup, I've got Ingress NGINX sitting in front of everything, handling SSL termination, path-based routing, maybe some basic auth. What changes?
So with traditional Ingress, you had this beautiful simplicity. One Ingress resource says, route traffic for example.com to my service. Your Ingress controller reads that, configures NGINX, and boom, traffic flows. It's been working this way since 2017.
Right, and every DevOps engineer knows this pattern. It's muscle memory at this point.
Exactly. Now, with Gateway API, that same simple routing requires 3 different resources. First, you need a gateway class, which defines what controller you're using, then a gateway, which represents your actual load balancer, finally, an HTTP route that does the actual routing.
That sounds like complexity for complexity's sake. What's the benefit?
Here's where it gets interesting. That separation of concerns actually solves real problems. In large organizations, who manages the load balancer is often different from who manages the routing rules. With Ingress, they're fighting over the same resource. With Gateway API, platform teams can own the gateway while app teams own their HTTP routes.
Okay, I can see that. But what about the actual migration? You can't just flip a switch.
No, and this is where it gets painful. Let's say you're using Ingress NGINX's custom annotations, things like nginx.ingress.kubernetes.io/rewrite target for URL rewriting. Those don't have direct equivalents in Gateway API. You need to use HTTP route filters instead, which work differently.
How differently are we talking?
Take rate limiting. With Ingress NGINX, you'd use annotations like nginx.ingress.kubernetes.io/limit RPS. Simple, straightforward. With Gateway API, rate limiting isn't even in the core spec yet. It's in the experimental channel, implemented differently by each controller.
So you're telling me basic functionality that people rely on might not even exist in the replacement?
It exists, but it's not standardized. If you pick Envoy Gateway, you'll use their rate limit filter. Choose Contour, it's a different API. Pick Trafic, different again. The portability promise of Gateway API only applies to the core features.
That sounds like vendor lock-in with extra steps.
In some ways, yes, but here's the thing. Ingress NGINX was already vendor lock-in. All those NGINX-specific annotations, those were never portable. At least with Gateway API, the core routing functionality is standardized.
What about performance? NGINX has been battle-tested for years.
Great question. Most Gateway API implementations use Envoy under the hood, which is plenty fast. We're talking sub-millisecond latency differences in most cases. But the real performance consideration is operational. With Ingress NGINX, you typically ran a few large controller pods. With Gateway API, you might run multiple smaller gateways for different purposes.
So more components to manage?
Potentially, yes, but also more flexibility. You can scale your API gateway differently from your web gateway. You can have different security policies, different teams managing them. It's the classic microservices trade-off. More complexity for more flexibility.
What about the alternatives to Gateway API? You mentioned there were other options.
Right. So you've got several paths. Trafic, HA Proxy, and Contour all have their own Ingress controllers that will keep working. But here's the catch. They're all also investing heavily in Gateway API support. The writing is on the wall.
What about just using a cloud provider's load balancer directly? Skip Kubernetes Ingress entirely.
That's actually what a lot of teams are doing. AWS Application Balancer, Google Cloud Load Balancing, Azure Application Gateway, they all have Kubernetes integrations now. You lose some portability, but you gain native cloud features like WAF integration, DDoS protection, global load balancing.
But then you're locked into that cloud provider.
True, but let's be honest. How many organizations actually move their entire Kubernetes infrastructure between clouds? The portability argument is often more theoretical than practical.
Fair point. So what's the timeline looking like for teams that need to migrate?
This is where it gets urgent. March 2026 is barely a month away. You need time to evaluate alternatives, test them, train your team, update your CI/CD pipelines, migrate gradually, and deal with inevitable issues. Realistically, you should have already started.
And what happens if you don't? If you're still running Ingress NGINX after the retirement date?
Then you're running unsupported software in the most security-critical part of your infrastructure. Every CVE that gets discovered becomes a permanent vulnerability. It's like running Windows XP on your company's web server. Stick around. In our final segment, we'll give you the exact checklist for planning this migration, plus some surprising options you might not have considered.
All right, let's get practical. If you're one of the 50% still running Ingress NGINX, here's your action plan.
Start with the assessment phase, I assume?
Exactly. First thing, audit your current Ingress resources. Run this command: kubectl get ingress -a -o YAML bind grep -e nginx.ingress.kubernetes.io. Every annotation that starts with that prefix is something you'll need to migrate manually.
Because those NGINX-specific features won't just port over.
Right. Make a spreadsheet. List every custom annotation you're using, what it does, and research the Gateway API equivalent. Some will have direct replacements, others won't. For the ones that don't, you need to decide, is this feature critical or can you live without it?
What about testing? You can't just swap this out in production.
Absolutely not. Here's the approach that's working for teams I've talked to. Run both in parallel initially. Gateway API supports this. You can have your new gateway running alongside Ingress NGINX, handling a subset of traffic. Start with non-critical services.
How do you split the traffic?
DNS is your friend here. Create new DNS records pointing to your Gateway API load balancer. Migrate services one subdomain at a time. API-new.example.com points to Gateway API, while API.example.com still goes through Ingress NGINX. That gives you a rollback path, too.
Exactly. When something breaks, and something will break, you just flip the DNS back. No emergency patches, no 3 a.m. debugging sessions. Well, fewer of them anyway.
What about teams that decide Gateway API is too complex? What are their options?
3 main paths. First, pay for support. ChainGuard's Emeridos will keep Ingress NGINX patched and secure. Figure about $30,000 per year for a small cluster, scaling up from there. For many enterprises, that's cheaper than migration.
But then you're paying for what was free.
Welcome to the reality of open source sustainability. The second option is moving to a cloud-native solution. If you're on AWS, the ALB Ingress controller is mature and well-supported. Similar stories for GCP and Azure. You lose portability, but gain simplicity.
And the third option?
Pick a different Ingress controller that's committed to long-term support. Traefik and HA Proxy both have commercial companies behind them. They're not going anywhere. But, and this is important, they're all adding Gateway API support too. So even if you go this route, you're probably ending up with Gateway API eventually.
It sounds like Gateway API is inevitable then.
For the Kubernetes ecosystem, yes. But here's my contrarian take. Not every workload needs to be in Kubernetes. If you're just running simple web apps, maybe it's time to reassess. Platforms like Cloud Run, App Service, or even good old VMs might serve you better.
That's a spicy take, suggesting people leave Kubernetes?
I'm suggesting people use the right tool for the job. If you're spending more time managing your Ingress controller than developing your application, something's wrong. The retirement of Ingress NGINX is a forcing function to reassess.
What should teams be watching for in the next few months?
3 things. First, Gateway API 1.3 is coming with better migration tools. Wait for that before you start any major migration. Second, watch what the major cloud providers do. They might release managed migration paths. Third, keep an eye on the Ingress NGINX fork attempts. The community might rally around a successor.
You think someone might fork it?
It's open source, anyone can fork it. The question is whether anyone can maintain it. Remember, the original team couldn't find enough maintainers. What makes a fork different?
Good point. So what's your key takeaway for platform engineers?
Don't wait. Even if you decide to pay for support or stick with Ingress NGINX somehow, you need to make that decision now. The worst position is being forced to migrate under pressure when vulnerabilities start appearing.
And longer term, what does this mean for how we build platforms?
This is the wake-up call our industry needed. We've been building critical infrastructure on top of volunteer-maintained projects and acting surprised when the volunteers burn out. The future is probably fewer, better-funded projects with sustainable governance models.
Or more commercial open source, where companies maintain the projects they profit from.
Exactly. And you know what? That might not be a bad thing. The myth of purely community-driven infrastructure has led us here, to the sudden retirement of software running half the internet's Kubernetes clusters. Maybe it's time we acknowledge that critical infrastructure needs sustainable funding.
Platform engineering is definitely getting more interesting.
That's one way to put it. Just remember, every crisis is also an opportunity. The teams that navigate this migration well will come out with better, more flexible infrastructure. The ones that don't, well, they'll learn some expensive lessons about technical debt.
Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development from AWS that's going to make platform engineers sleep better at night. Amazon CloudFront just announced mutual TLS support for origins, which is a game changer for security-conscious teams.
Oh, this is huge. So now you can actually verify that requests to your origin servers are genuinely coming from your authorized CloudFront distributions?
Exactly. It eliminates that nagging worry about unauthorized access. AWS announced this just yesterday, and it's already getting a lot of attention from teams managing sensitive workloads.
This is definitely going on my list of things to implement. Speaking of security concerns, have you heard about this Docker Dash vulnerability?
Yes, and it's pretty serious. InfoSecurity magazine reported that there's a critical flaw in Docker's Ask Gordon AI assistant. Attackers can exploit unverified metadata to execute malicious instructions.
Wait, so the AI supply chain is the weak link here? That's actually not surprising given how fast these AI tools are being integrated everywhere.
It really highlights how we need to be extra careful with AI-powered tools in our development pipelines. The vulnerability allows for some pretty nasty attack vectors.
Definitely something to patch immediately if you're using Ask Gordon. Now, switching gears a bit, Red Hat published an interesting piece about the evolution to sovereign techcos.
This one caught my eye, too. They're talking about how communications service providers need to transform into techcos using StarHub as a case study. The three pillars they highlight are polycloud agility, secure agentic AI, and digital trust.
Polycloud is becoming the default architecture for large enterprises, isn't it? No more single cloud strategies.
Absolutely, and they make a compelling case for why this transformation is necessary for CSPs to stay competitive. Finally, for those who missed KubeCon plus Cloud Native Con North America, CNCF just released a highlight video.
I saw this. The video really captures the energy of the event, the diversity, the community connections. It's making me even more excited for the next one.
It's a great reminder of why these in-person events matter so much for our community. The CNCF blog post emphasizes how KubeCon isn't just about the tech, it's about the people and connections.
Couldn't agree more. That wraps up this week's news.
That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platform-engineering-playbook.com for more resources and guides. Until next time.